All right, guys. Let's talk about one more thing before your test. Now, this is going to have a couple different things involved. One thing you can note right away is if you see the top degree is bigger than the bottom degree, this is going to have an asymptote, but it's going to have actually a slant asymptote. So it's not going to be perfectly horizontal. It's one that's going to present itself as an equation. So let's just jump into it. You're going to find nothing's really new here. It's just an interesting variant that's worth talking about. So very first thing when you see a problem like this, you should think, I need to factor this guy, and you do need to factor this guy. So let's go ahead and get to it. The top we see has a common term of x, so I'm going to pull the x out. That will leave us with x squared minus 9. That will further factor into x, x plus 3, and x minus 3. Okay. On the bottom, we have a common term of 3 that we need to pull out, and we end up with x squared. That'll be minus 2x plus, minus 3. Okay, and so we can further factor that quadratic. Let's see, x times x will give us x squared. 3 and 1 will give us 3 at the end. If we go minus 3 plus 1, we'll end up with the minus 2 in the middle. And so immediately this tells us we have two discontinuities because the bottom has two numbers that we cannot use, and those numbers are going to be x equals 3, and the other one is going to be x equals negative 1. Now, the other thing we can note is that we do have a minus 3 on top and a minus 3 on bottom, which means we can classify this as actually being a removable discontinuity, which is really just a hole. This guy, the plus 1, which ends up with a negative 1 discontinuity, that's going to be a vertical asymptote because we can't remove it, so it's going to be a hard break. So we can start putting things in our graph that make sense of that. So we have a hole at 3. We're going to have a vertical asymptote at negative 1. And so negative 1, let's go ahead and draw on this. There. And we have a hole at 3. I don't know where that's going to be. I'm just going to take a guess and put it like right here for now. Okay, we might have to adjust that later, but that's going to be our hole. Now that we have a depressed, we removed a term, we can actually use just the remainder part of the function to do the rest of our analysis. So we'll see we have this function y. On top we just have an x times x plus 3, and so that becomes x squared plus 3x. Again, these are gone, so I'm not going to consider them. On the bottom I just have 3 times the quantity, well actually let's go 3x plus 3 on the bottom. Okay, so now we can find our horizontal asymptotes. Now there's no shortcut here because we still have a smaller degree on the bottom than the top, and so we're going to have to do some long division, which is okay. And so we have 3x plus 3, and we're dividing that into x squared plus 3x. So we're calling long division. We're going to focus on our leading terms. What times 3x will get us x squared? Now that's 1x squared, so we got to multiply by a third to get 1, and then x to get x squared. And so the first term will be x squared. 1/3 times 3 is going to be 1, and then we have the x. So we can probably just drop that 1. The 1/3 times 3 is 1, right? Now we're going to go ahead and subtract, so we're going to subtract the whole line. X squareds are gone. 3x minus 1x will give us 2x. Okay, and then we have nothing else, so now we can continue. So we have 3x goes into 2x. Now again, we're going to end up with a fraction, but that's okay. If we multiply by 2/3, that'll end up with a 2. So 2/3 times 3 is going to be your 2x. 2/3 times 3 again is going to be plus 2. Now we're subtracting here, so our remainder is negative 2, but of course, given the limit, negative 2 has no effect, and so we end up with this as our asymptote. Now this asymptote is going to be a slant asymptote. Slant meaning it's defined to be a line rather than going to be a horizontal, but that doesn't change our what we think about in terms of end behavior. Okay, so we can actually add this to our graph right now, and this is just going to be estimate, of course, but we have a y-intercept of 2/3, which is roughly there, and then we're going to go up 1 over 3. So up 1 over 1, 2, 3, up 1 over 1, 2, 3. That's good enough to define more or less what our line is, and so we're going to have this nice slant asymptote right here. Okay, so we have a vertical asymptote, now we have a slant asymptote, and again, I don't know if that hole's in the right place, but we can move it later. Now we still have to encounter the question, can I use this as part of my, or can I cross this, excuse me, as part of my study? And so I'm still trying to propose, will this ever equal this? Now this is going to look like some crazy algebra, but we can't really get away from it. So let's go ahead and set it up. So we need to figure out if 1/3 x plus 2/3 is the same as x plus 3, x squared plus 3x times 3x plus 3. Now, we're going to do this without rewriting a bunch, but in the end, I do have to multiply these two things together. So we have to do some distribution. So we'll take 1/3 x times 3x. That's just going to be an x squared. We'll take 1/3 x times 3, and that should just be, let's see, plus 1x. And now we're going to take 2/3 times 3x, and that should result in a 2x. And then 2/3 times 3 is going to be plus 2. Now that's going to be equal, of course, to x squared plus 3x. Now we can go to simplify. Well, the x squared kills the x squared. There's 3x's killing that 3x's. And so we just end up with 2 is equal to 0. 2 equal to 0 is a nonsense result, so no crossing for us. Which is good news, because now we know that our regions will be completely kind of trapped by our asymptotes. Now let's talk x-intercepts and y-intercepts. So again, we're dealing with this function y is equal to x squared plus 3x over 3x plus 3, the reduced version of this function. And so if we want the x-intercepts, that's going to be when y equals 0. And so we have 0 is equal to x squared plus 3x over 3x plus 3. Now if we do cross multiplication, that will end up being 0 right away. And so what we really have is 0 is equal to x squared plus 3x. Now this can be solved by a lot of different ways. It's quadratic. I think I'm just going to factor this. So 0 is equal to x, it's going to be x plus 3. And so that means x is going to be 0. X-intercept can also be negative 3. Now we expected this, of course, because it's a quadratic with a power of 2. So we end up with 2. We expect to end up with 2 roots. The y-intercept is going to be the y value when x is 0. And so we actually have quite a few things that 0 out. So we end up with 0 squared plus 3 times 0 all over 3 times 0 plus 3. On top, we just end up with 0. The bottom ends up being 3, but that doesn't matter since the top is 0. Our y-intercept is going to be 0. Let's go put some of that in our graph. And so y-intercept is going to be 0. So we're actually going to sneak in here and cross the axis right there. We'll also have that's also going to be your x-intercept, which I have. And we're going to have another x-intercept at negative 3. 1, 2, 3. So we kind of get a picture of what our graph is going to be. My guess is this hole's in the wrong place. It's going to be actually down here somewhere. Okay, let's go ahead and get our information wave in. Remember, this is our x-axis. And so let's put in our x pieces that we know interrupt our x-axis. We're going to have a vertical asymptote at negative 1. I'm using an x to make sure in my head I know it's an asymptote. Excuse me. We're going to have an x-intercept at 0. And that looks like it's it. Oh, I'm sorry, we have one more. I forgot, negative 3. So we have another one at negative 3. All right. So information wave, if we look at our leading coefficients, they're both positive, which means it's going to be a normal wave. So we should start with a positive, start right here, cross our number here, cross our axis here, and cross our axis here again. And so that means per region we can start mapping out our behavior. So it looks like starting farthest left, we're going to be positive until we hit our first x-intercept. And so we're going to start up here by the, so in our region, let me help you see where this is. Yep. So our first region goes all the way to x equals 0. So this is our first region on our graph. And so we're going to be positive up until we hit that axis. Now this is going to be hard to do. So we're going to come in from our end behavior, because that's what it behaves like long term. We're going to cross this hole, and then cross the axis at the origin, and then dive straight down because we can't cross a vertical axis ever. Our next region happens after the intercept and before our asymptote, which is this right here. And so just like it's predicted on our wave, it's going to be all negative, so it's all below the axis, which it is. Our last region is after the asymptote, second to last region, after the asymptote, before the intercept. We've got to be positive, so we start up here by our asymptote and go all the way down to our intercept, and we've got to stay above the axis. Our last piece is after the x-intercept is we're going to be completely negative, and so that's going to be, oh, I forgot to put pink in here, sorry guys. So that's a pink region here. And then our yellow region is past the intercept, and we're going to be completely negative because we're below the x-axis. And so that means it crosses over and hugs our line. Okay, so last piece, let's talk about our domain and range. Let's start with domain because that tends to be easier to pick out the breaks. So that's how you spell domain. Okay, so domain, we know we're going to start at negative infinity. Looks like we're going to have not going to have a break until we get to our first x-intercept. I'm sorry, vertical vertical asymptote at x equals -1. So that's going to be -1. We'll start again after -1. That's our asymptote. Go to our hole at 3. And then after 3, go all the way to infinity. So we have 2 breaks in our graph. That means we have 2 breaks in our domain. Now the range is going to be a little bit weird because in this case we're not crossing at all our vertical asymptotes, but we are taking all the values. And so if you think about either one of these two red lines, they both are going to go from negative infinity to infinity. Let me try to demonstrate what I mean. And so if you think about the limit as x goes to negative infinity of this line, well, it's going to continue downward. And so that's going to go all the way to negative infinity. Like that's going to continue downward until it reaches the lowest possible value, because right now you can see it's angling downward. On the other end of things, if I think about the limit as x goes to infinity of the red line, this is going to go all the way up to infinity. This makes sense because the red line is increasing now and the asymptote's increasing. So on our range, we're actually going to have a full negative infinity to infinity graph. And so again, with a slant asymptote, something just a little bit unusual, something that you may not have seen. So if you're watching this, thank you very much. Thank you for preparing for tomorrow's test. See you tomorrow.